Hello again, I'm Kevin. Here we are in Utah County. This is Rock Canyon, and it's part of Provo, Utah. Today we're going to have a discussion about this geological feature right here. Here in the mouth of the canyon, you can see this fence comes along just like this, a little bit flat, and then suddenly right here, the fence dips down at a pretty sharp angle. This geological feature right here goes across that way. You can see some houses on the left, some houses on the right. And what is this geological feature we're talking about today? Well, of course, this is the Wasatch Fault. So this section of the Wasatch Fault is called the Provo segment of the Wasatch Fault. The Wasatch Fault is about 250 miles long, and it goes from Idaho in the north all the way down to central Utah, and it's broken up into 10 segments. This one is the Provo segment of the Wasatch Fault, but we're about to go see the Nephi segment of the Wasatch Fault. Now, right here, we have a fault scarp. As you can see, the ground has been displaced, probably around 6 feet. But if you remember from last time, we weren't down here, we were up further in the canyon. Now, if the fault is up there and down here, that's kind of a problem. But of course, faults are messy. They're not straight lines drawn in the sand. They're more fault zones, and that's what we have here. During an earthquake, either that portion of the Wasatch Fault or this one could rupture and cause an earthquake. Okay, so right here we have the Nephi segment of the Wasatch Fault. It's one of the most recent faulting events on the Wasatch Fault is right here. You can see the fault scarp as the mountain was displaced in the last earthquake, which happened about 400 years ago at this particular location. It was probably about a 7.0 earthquake and gave about 6 feet of displacement. You can see part of the fault scarp here, which comes down and just suddenly angles downward. This is part of the Nephi fault segment that we discussed earlier. And as I said, it was only a few hundred years ago that there was an earthquake here, about a 7.0. It's pretty recent in geological terms. And the fault scarp here is about 6 feet tall. Now, in order to understand the Wasatch Fault, we have to understand what kind of fault we have here. And of course, from junior high school geology, you probably learned that there are reverse faults where one plate is riding up over another one. We have strike-slip fault where two plates are moving across from each other. And we have what's happening here, which is part of the plate is moving downward. So here in Utah, the mountains aren't rising, the valleys are falling. So the Wasatch Fault here, in order to understand it again, we need to understand the history of Utah. Now, Utah was once the western edge of the North American continent. Back this way back in the past, was all continent, and out that way, toward California and Nevada, was just ocean. And going back about 200 million years ago, that was the case, back when Pangaea still existed. But Pangaea began to break up, and as Pangaea broke up, east of us, back in the Atlantic Ocean now, the continent began to spread apart. And that meant that North America began moving westward. And as it moved westward, it encountered different kinds of landforms. First of all, it began gobbling up the oceanic plate, and it became a subduction zone. As rock was subducting under here, it created volcanic chains, it created mountains, and it did that over a period of time and encountered several island arc chains like modern-day California, which was an island arc chain that hit the edge of North America. Now that force that once existed, which raised these mountains up, began to die off as the fault in California changed from a subduction zone to a strike-slip. That means that pressure, which once pushed these mountains up into the sky, was released. And now, where you had all this built-up pressure, it's been relaxed, allowing the valley floors to fall down. If you think about it, the Wasatch Fault is kind of like a giant landslide that's 250 miles long, and over a period of millions of years, this slow creeping landslide occurs, and every time it moves down, there's an earthquake. That's really kind of how it works. It's a giant landslide.